Learn like a pro.
Hey everyone, and welcome. Today, we're going to build something absolutely essential, a kind of universal toolkit for all of science. It doesn't matter if you're into chemistry, physics, or biology, everything, and I mean everything, starts with being able to measure things precisely and reliably. It's the bedrock of it all. So just think about this for a second. How is it possible that a researcher in Tokyo can perfectly repeat an experiment that was just done in a lab in Berlin? I mean, if their measurements didn't mean the exact same thing, science it just wouldn't work. Well, the answer is actually pretty elegant. It's a shared universal language, and it's built on 5 core foundational pillars of measurement. Pretty much every experiment you can think of, no matter the field, is going to rely on these standards. So let's break them down. Okay, so our first 2 pillars are mass and time. Mass is basically just the amount of stuff in an object. Now, in the lab, you might hear about grams all the time, but the official international standard, or what we call the SI unit, is actually the kilogram. And for time, the standard is the second, which we can capture super precisely with tools like the digital stopwatch you see right here. Moving on, we've got length and temperature. So pillar number 3, length is just the distance between 2 points, and its standard is the meter. Simple enough, right? But pillar 4, temperature. Now this one might surprise you. The official SI unit isn't Celsius, it's actually Kelvin. And that brings us to our final pillar, volume. Its SI unit is the cubic meter. Now, when we're working with gases, a tool like this gas syringe is an absolute game changer. It doesn't just let us collect a gas, it lets us actually track the speed of a reaction in real time. But while a gas syringe is perfect for gases, liquids, they're a whole different story. Yeah. Measuring liquids is a completely different ballgame. You've got this whole lineup of different glassware you could use. So the big question is, how do you know which one to pick? Well, it all boils down to one simple, crucial word: precision. Think of this slide as your apparatus decision-making cheat sheet. It's all about matching the tool to the task. So let's say you need extremely high accuracy, like you're making a pharmaceutical solution. You're going to reach for a burette, which can measure down to the nearest 0.05 cubic centimeters. That's incredibly precise. But what if you just need a rough estimate, like for a simple classroom experiment? Well, then a measuring cylinder is totally your best bet. So you've picked the perfect tool for the job. You're all set to go, right? Not quite. See, having the right instrument is really only half the battle. The other half, well, that comes down to your technique. Okay, this is where technique is absolutely crucial. We need to avoid something called parallax error. You see that little curve at the top of the liquid in the tube? That's called the meniscus. To get a truly accurate reading, your eye must be perfectly level with the bottom of that curve. If you look from above or from below, it's going to totally skew your result. It's such a simple little adjustment, but it honestly makes all the difference in the world. Another huge part of good technique is knowing how to speak the universal language, even if your tools don't. Since scientists are constantly switching between common lab units and that official SI standard, we need a way to translate between them. The best way to think about it is that we're building these simple measurement bridges to make sure everyone, everywhere, is on the exact same page. Here is a perfect example for temperature. In the lab, you're probably going to be using Celsius, but to communicate in that universal SI language, you use this super simple mathematical bridge. You just add 273 to whatever your Celsius reading is, and boom, you've got the temperature in Kelvin. Easy. And we see the exact same idea with length. The official SI unit is the meter, but a really common lab unit is the centimeter. The bridge between them? It's that simple conversion we all know. 1 meter equals 100 centimeters. It's all about making that translation seamless. And here it is, your complete master measurement blueprint. We've laid out the 5 pillars: mass in kilograms, time in seconds, length in meters, temperature in Kelvin, and volume in cubic meters. And we've even looked at their key instruments. This dashboard right here is your guide to precision, accuracy, and the universal language that really makes global science possible. So now you have the blueprint. You get the tools, you get the techniques, and you get the universal language of measurement. Every single major scientific breakthrough, from discovering the smallest molecule to mapping the largest galaxy, it all started with these fundamental steps. So the only question left is, where will your measurements take you?